Hello, welcome again. We are solving Indian Forest Services Mechanical Engineering Paper 2 of year 2024. Question number 1 is a 3-cylinder 4-stroke cycle SI engine having bore 68.5 mm and stroke 72.0 mm runs at 3000 rpm with air fuel ratio 15:1 and valve indicate the mean effective pressure 10 bar. Calorific value of fuel used is 44,000 kilojoules per kilogram. Mechanical efficiency is 0.85, combustion efficiency is 0.97, and volumetric efficiency is 0.9. Density of air is 1.18 kilogram per meter cube. Determine 1. Inlet power in kilowatt. 2. Rate of air flow into the engine in kilogram per second. 3. Brake thermal efficiency. 4. Brake specific fuel consumption in kilogram per kilowatt hour. So first part is to calculate indicated power. So that for that formula is indicated mean effective pressure into volume of air sucked per second. So A, L, and K by 2 represent ideal volume of air sucked per minute. If we divide by 60, then it will be ideal volume of air per second, because AL is volume, swept volume, and is revolution, and divided by 2 is for 4 stroke, because in 4 stroke in 2 revolution once the air is sucked, K is number of cylinders. If we multiply it by volumetric efficiency, then it will be the actual volume of air sucked per second. Okay, so now K is number of cylinders, that is 3. L is stroke length, that is 72 by 1000 meter. Volumetric efficiency is 0.9. Area of cross section is pi by 4 into 68.5 by 1000 here, because the bore is given as 68.5. RPM is given as 3000. So putting this value, we get IP as 17901.4 watt. Okay, and volume of the charge entering per second per cylinder is in meter cube per second. So that part A, L, and K by 60 by 2 into volumetric efficiency. That part is your volume of charge sucked per second. So putting the value, we get 0.00596 meter cube per second. So this is air plus fuel. Okay, now air fuel ratio is given as 15. So air plus air by air fuel ratio. Putting fuel as air by air fuel ratio, we get air as volume of air as 0.00559 meter cube per second. So as density of air is given, that is 1.18. So mass of the air, so that we have calculated for one cylinder, because here we have not used K. Here we have used K, here we have not used K. So that is for one cylinder, and for 3 cylinder, if we multiply by 3, then it is 0.0198 kilogram per second. Okay, so now next part is to calculate brake power. IP has been calculated. Mechanical efficiency is given. So mechanical efficiency BP by IP. So BP is your 1526216.19 kilowatt. So next part is your specific fuel consumption, brake specific fuel consumption, that is mass of fuel burned per hour divided by brake power. So mass of fuel burned per hour is that part, or we can say that is the mass of the air sucked, divided by 50 mass of fuel. Okay. So that is your mass of fuel sucked per second, and that will be your per hour if you multiply by 36,000. So where the BP is in kilowatt, so that comes as 0.3122 kilogram per kilowatt hour.